So welcome again. Tuesday night, April 9th, 8 to 9 p.m., Math 123, Section 04D. We are looking at Section 13 and 14 today, measurement conversions and rates, and then applications of conversions and rates. And so we have a lot of material, actually, since we're doing two sections. Again, I remind you that the work for this unit, the absolute deadline, even for late work, is Saturday. Project is due on Saturday. Exams need to be completed by Saturday, exam 2. And then today we have web work 13 and 14, and then a dosage calculation report, and then quiz 6, discussion board 6, and that's all due April 17th. So next Wednesday, okay? Now, when you do this dosage calculation report, be complete, okay? You should have like at least a paragraph, which is, 5 to 7 sentences at a minimum, probably 2 paragraphs to do a good job on this particular assignment, as well as your chart with the information you need to provide. All right, so we're going to start here on page 157 in your book, and we're looking at this thing called the factor label method. And the factor label method really is, so factors are things you multiply together, and labels are the units. So like weeks here, days, those are the units, or the labels we call them. And then since we're multiplying, these are called, like this whole thing is called a factor. There's a factor. And we have conversion factors that we'll be using our identity ratios. So an identity ratio is something that represents 1. So 7 days and 1 week, those are the same thing. So 1 week and 7 days, same thing. So we have identity ratios for converting between days and weeks. And depending on what we have and what we're trying to get to, that will determine which is the numerator and which is the denominator, the days or the weeks. So let's look at this example number 2. It says on an average pregnancy is 280 days. How many weeks is this? And so we say, okay, since we're starting with days, we want days to be in the denominator of our conversion factor so that they cancel out, because with multiplying fractions, you can cancel numerators with denominators. So 1 week is 7 days. And so we'd have 280. So we multiply across the top, multiply across the bottom, 280. Weeks is the units that's left. And then we would just reduce it to 40. So on your formula sheet, which is that yellow page in your book, let's see, I get my copy here. So on page 235, we have all these conversions. And so the front side of this page is really what we're going to be using on this exam, mostly. Okay, well, I guess your third exam is the final, so it includes everything, but 2/3 of it will be what we're doing in this unit. So the first ones we're going to look at are on page 159. They're the length, volume, and weight conversions for the U.S. customary units. So these are foot, yard, mile, cup, pint, quart, gallon, pound, and ton, and ounces. And so it says, what identity ratio would you use to convert 27 feet into yards? So again, what we want to think about is, what are we starting with, and what do we want to get to? So when we have something like 27 feet, we want to write it as a fraction. So it would be 27 feet over 1. So we want to know, what would this piece be right here? What would we multiply by to get yards as our answer? So which of these conversions? And so we look at these and we go, oh, this one has yards, this one has feet. We want feet to be in the bottom because we want to be able to cancel feet out and have yards left. So 3 feet is 1 yard. So that's the thought process. And when you do this, you want to make sure you include the units, because the units, feet, yards, that's what's making this all make sense. That's what makes sense. That's what makes the numbers make sense, because that tells us if we have things in the right places. So we're using 1 yard over 3 feet because we want the feet to cancel. So this says convert 15 yards to feet. So in this case, we're starting with 15 yards. And again, I'm going to put it over 1 so we have a fraction times. Now we want to get feet for our answer. So we want to get rid of the yards. So where will the yards be in our conversion? On the top or the bottom? It's going to be on the bottom. So 1 yard is 3 feet. So now we can see the yards cancel out. We're left with just feet, and we're going to multiply across the top. 15 times 3 is 45, and then 1 over 1 times 1 is 1, so we don't need to put that 1 in the denominator. So we have 45 feet. And that's what we were asked to find. We're converting it into feet. So let's see. Why don't I give you the next two, number 3 and number 4, and I'm just going to have a little timer going out here, and I'm going to put 2 minutes. And when you have answers for number 3 and 4, we'll go ahead and take a look at them together. So I'm going to give you 2 minutes to work on number 3 and 4. When you're done, throw your hand up in the hand raise feature, and then we'll talk about the answers. About 10 more seconds. All right, so let's take a look at these. And so for number 3, go ahead and put your answers in the chat box if you got an answer for number 3. We'll take a look. I think we're have to round to the nearest tenth, it says, so that helps with getting our answers all to be the same. So 221 inches, we're going to put that over 1, right? And we're going to put our conversion factor in. So this This time we want inches to be on the bottom, feet on the top, and you all have figured out that the conversion is 12 inches is 1 foot. So we see that the inches cancel out, and we're just going to do 221 divided by 12. And then that gives us feet. So 221 divided by 12 is 18.4. All right, and then how about number 4? Perfect. It looks like we're getting 4.5 gallons. Awesome. So 18 quarts. Again, we're going to put it over 1. Then we have our quart and gallon conversion. And so we need quarts on the bottom, 4 quarts in 1 gallon. So we see that quarts cancel out. 18 divided by 4 is 4.5. Awesome. So let's move to page 160. Hopefully this has been a review so far. And it'll continue to be a review as we go through most of this today. So it says here, so far the examples you have seen and worked require only one identity ratio, but sometimes you'll need more than one identity ratio to make your conversions. And consider the following example, converting gallons to ounces. So we don't have on our formula sheet a straight gallons to ounces conversion, even though you might know what it is. Of course, it's already written here, 128 ounces in 1 gallon. But the way we get there is we start with 1 gallon and we go to the next smaller unit. So notice that when we're going from a large unit to a small unit, we end up multiplying. So we're multiplying all these. So gallons cancel out. Now we're going to go from quarts to pints. Notice how quarts are on the bottom to make that work. Pints are on the bottom next to make that work. And then cups, and we're left with ounces. So 4 times 2 times 2 times 8 is 128 ounces. So let's see how this works again with number 6. Math 123 lasted 14,000 seconds this week. How many hours is this? So we know that we don't necessarily have a conversion that goes from seconds directly to hours. And so we're going to have to go through minutes. So we have how many minutes is seconds, or how many seconds is a minute? So we know that there are 60 seconds in 1 minute. So that gets rid of seconds. Now we have minutes. So we have to go minutes into hours. So there are 60 minutes in 1 hour. Cancel out minutes, and we have hours left. So we're going to do 14,000 divided by 60 and then divided by 60 again. Now I want you to notice that we're going from a small unit, seconds, to a large unit. Notice that we're dividing this time. So when you go from a large unit, gallons, into a small one, you end up multiplying. And when you go from a small unit to a large, you end up dividing. So 14,000 divided by 60 and divided by 60 again is 3.89 or 3.9 hours. So thank you, Megan. I see that you have that in there, and Kendra and Kayla. Awesome. So number 7 says, if you cook 3 quarts of soup, how many cup-sized containers will this fill? So we're going to change 3 quarts really into cups. But we don't have a direct conversion from quarts into cups. So we're going to go through a couple here. And Megan, you're awesome. So let's see. Quarts, it says here 1 quart is 2 pints. So now we have quarts are gone, but now we have to get rid of pints. So 1 pint is 2 cups. Now we have cups as our final unit. Pints cancel out. So we have 3 times 2 times 2, which is 12. So we would say 12 cup-sized containers. And the last one of these says, if we had a measurement in inches and wanted to convert it to miles, what steps would we take? So why don't you someone want to just tell us? You have inches, you want to convert it into miles. Let's say you have 100,000 inches. How would you convert that to miles? That's what this question really is. Yeah, so if we look at our conversion sheet, we have a miles and feet conversion. So we go from inches to feet and then feet to miles. That's what we would do. Good job. Inches to feet, feet to miles. So it would look like, so we'd have, so for my example, 100,000 inches, we would have to do 1 foot, 12 inches to get rid of the inches, and then 5280 feet, one mile on the top, and then notice how the feet and the inches would cancel out, and we'd still be left with miles in the numerator, and that's what we're looking for. So that's how we would handle that. Okay, any questions on those US customary units at this point? Or I should say, what questions do we have on those? Because the easy answer is, no, there's no questions, Mr. Falutz. All right, well, let's look at page 161. So on page 161, we're looking at converting within the metric system. Now, the metric system is all based on multiplying and dividing by 10 or moving the decimal. So when you multiply by 10, you move the decimal to the right. When you divide by 10, you move the decimal to the left, and that's what this represents, this chart. And there's a little, oh my gosh, I just forgot the name of what it is, where you take the first letter and make a word out of it. I don't know why I can't remember what that is with my language arts license. Okay. Oh my gosh. So it's like King Henry doesn't usually drink chocolate milk is what people use as that, like a pseudonym or something like that. I don't know what it's called. I can't remember. So K, King, H, Henry, D, doesn't, U, usually, drink, D, C, chocolate, M, milk. So kilometer, if we were using meters, kilometer, hectometer, decameter, meter is the unit, decimeter, centimeter, millimeter. As you go from left to right, you're getting smaller in unit. Oh, there you go. Thank you, Ashley. That's good too. Kings have diamonds, but diamonds cost money. Oh, so the but would be the unit. Okay, good. So let's look at number 3 here. It says the average racehorse weighs 500 kilograms. How many grams is this? And so the way I would do this is I'd say, okay, I'm going to start with 500 of these kilograms. My decimal is at the end of my number if it's not in the number. And I need to get to grams. So I'm going to move the decimal 1, 2, 3 places. So 500. And I'm going to move the decimal 1, 2, 3 places to get grams. So that's what I do is I just move the decimal. Oh, B is for base unit. Thank you, Ashley. So 500 kilograms, kilo means 1,000, so it's 500,000 grams. That's what that means. So if you wanted to use the interpretation of kilograms, this really says 500,000, since kilo means 1,000, grams. And that's what that is. So this just shows what I just did, moving the decimal point. So if we look at number 6, it says 5.2 kilograms is how many centigrams. So again, we're over here at 5.2. We're going to move the decimal over to this spot. So we're going to move the decimal 1, 2, 3, 4, 5 places. So 5.2. So there's 1, 2, 3, 4, 5 places. And notice how we're going from a large unit, kilogram, to a small unit, centigram. So we're multiplying, just like I had mentioned earlier. Now, this number of spaces you move does not define the number of zeros that you put on the end. Notice we move 5 places, but there's only 4 zeros there. It defines the number of places you move the decimal. So let's look at number 7, 5.2 kilograms, and we're going to change that into hectograms. And so we look and we say, okay, we're moving this from kilograms to hectograms of 1 decimal. So I'm going to move the decimal place 1 spot. 52. Thanks, Kayla. Whoops. Oh, man. Let's try that again. 52 hectograms. And then how many grams is this? Again, 5.2 kilograms. We're going to go 1, 2, 3 decimal places. So 5, and then it's 1, 2, 3 decimal places. 5,200 grams. So the metric system is just about moving the decimal on that chart. How many places do you need to move it? If you move it to the right, you're multiplying. If you move it to the left, you're dividing. So, let's think about this. If I don't have this example up here, but what if I had 750 centigrams? And I want to know how many grams is that? So if I'm over here at 750 centigrams, how many grams is that? My decimal point is at the end, remember, if it's not in the number. I have to move my decimal 1, 2 places to the left. So I've got to take it 1, 2, so it would be 7.5 grams. All right, so when you're moving to the right on this chart, you're multiplying. When you're moving to the left, you're dividing. And then putting all this together, we look at converting between US customary and the metric system. So this is going to be right in the middle of that yellow page 235, conversion between US customary and metric system. So we have some conversions there. When you have assignments, these are the conversions you're going to use. Don't look them up on the internet or whatever. Just use these ones, okay? So here we have an inch is 2.54 centimeters. That also means that 2.5 centimeters is 1 inch. 1 yard is 0.9144 meters. That means that 0.9144 meters is a yard, and so on. And the little squiggly line like that one means that it's approximately that value, not exactly that value. So as we look at this, let's see. I'm going to go down to example 1. Notice we're converting 2 inches into centimeters. So 2 inches over 1, we need inches to be on the bottom so that centimeters is left. Centimeters, number example 2, 24 centimeters into inches. Again, centimeters is on the top of our fraction, so in our conversion, we need the centimeters to be in the denominator. And then example 3 shows several conversions. It looks like we're going from centimeters to yards. So we start with 245 centimeters over 1. So we're going to change centimeters into inches because this is a customary unit. We don't have a conversion from inches, or excuse me, we don't have a conversion from centimeters into yards. So we're going to convert from centimeters into inches first. So there's the first conversion. Then we're going to convert inches into feet and feet into yards. So the metric conversion into US customary was this first step right there in this case. All right, so let's use these conversions in some examples. The first example I have here is about guests at a party, 50 liters of wine, how many gallons of this? And so again, we're going to start with our 50 liters over 1. And we're going to look for a conversion from liters into gallons or something like it. And if we look right in the very center of the page, it says 1 quart is approximately 0.9464 liters. So that's where we're going to make our conversion into the US customary. Now the liters have to be on the bottom, so we're going to put the 0.9464 liters on the bottom and 1 quart on the top. Now that gets us to quarts, but that's not what we're trying to find. We're trying to find gallons, so we need to multiply the conversion for quarts and gallons, and we know that that is 4 quarts is 1 gallon. Notice how quarts are on the bottom so that they cancel out. We're left with gallons. And let's see, Kelsey got 13.2. Did anybody else get the same? I got 13.2 also. All right, so I grew up in a family of grape farmers. Like my relatives all farm grapes out in Pennsylvania along the Erie Lake shore, 50 liters of wine. Well, at our parties, it's more like 50 gallons of wine. How exciting is that? All homemade. They are suppliers of Welch's Corporation, so oh, how fun that is. Number 2, a person weighing 200 pounds weighs how many kilograms? So this is one that will be one you want to make sure you know, okay? 200 pounds into kilograms. So do we have a pounds to kilograms conversion? We do. All right. So we want the pounds to be on the bottom. So that means 1 pound is on the bottom. So the unit cancels out. And 0.4536 kilograms is in the numerator. So this dosage calculation assignment that you have, that's where you're going to need this, okay? So we just multiply 200 times 0.4536, and we get the number of pounds that this 200 pound, or excuse me, we get the number of kilograms that this 200 pound person weighs. 90.72, 91-ish kilograms. Awesome. So let's do, I don't think we have to do number 4, grams into ounces, because we have a direct conversion for that one. So that one, we'll just say that's a direct conversion. I'm not going to spend the time on it. Number 5, 70.6 kilometers per hour. How many meters per hour is this? Well, that one's a little bit different. So even though it's one conversion, we'll still do it. I want to show you how we set this up. Kilometers per hour. So the divide line means per. So we want to have meters per hour when we're done. So we just have to convert the kilometers into meters. So 1 kilometer, remember what kilo means, it means 1,000, would be 1,000 meters. And so we're just multiplying here. Let's see, move the decimal 3 places. 70760. So the fastest racehorse ever recorded ran 70,760 meters in an hour. Now I promise you the horse didn't race for a whole hour, but that's how fast they were going. They probably ran for about 2 minutes. I think there's a big race coming up in about a month, somewhere close to Indiana. All right, so let's move further along in page 164 and look at these rates. Let's see. So it says, recall that a rate is a ratio between measurements with different units. A common example is the speed of a car. Suppose a car is traveling 35 miles per hour. Remember, that's what it looks like this right here, right? Miles per hour. And it wants to know how many feet per minute is this. And so this takes what we just did a little bit further. So in the last example, we converted, whoops, I don't have it up here anymore. We made one conversion when we had two different units. Now we're going to make two conversions. We're going to have to change the miles into feet and the hours into minutes. So notice how we start with hours on the bottom. That means when we do our conversion, hours has to be on the top because it's feet per minute. That means that minutes are going to be on the bottom. So 5280 feet per mile, and then 1 hour is 60 minutes. So we're going to multiply 35 times 5280 and then divide by 60. And that does get us 3,080 feet per minute. So again, the whole key here is watch where those units are. And we could have done this like the note on the bottom there. We could have converted the time first, 1 hour, 60 minutes, and then the miles into feet. So then we could have done the 5,280 feet, 1 mile, and see how the miles cancel out still, the hours cancel out, and we're left with feet over minutes. So we get the same result. So the order of the conversions doesn't matter. It's where the numbers and the units are placed that makes all the difference. All right, so let's finish this. Looks like we're going to finish section 13 up here with these last two examples. So I'm going to do that with you, and then hopefully we have time to work in a group as we do section 14. So a professional soccer player can kick a ball 122 kilometers per hour. How fast is that in miles per hour? So again, this is just a one-step conversion. We're changing kilometers into miles, right? So 122 kilometers per hour times, and we want to end up with miles per hour. So we need to keep the hours and get rid of the kilometers. So we're looking for a conversion that converts between kilometers and miles. And we have one. 1 mile is 1.6093 kilometers. So notice how the kilometers cancel out. We have miles on the top, hours on the bottom. We're all set and we're in business. So 122 divided by 1.6093, essentially 76 miles per hour. So you guys, looks like 75.8 if you take it out of decimal. Awesome. Last one here on this section 13. Suppose the resting heart rate is 70 beats per minute. How many times will it be in an hour? And I want you to give me a hand raise when you have that one done. All right, so I'm a little bit concerned because only 4 of you have your hands raised at this time, and more of you should. So something's going on here. Either you're not doing it, waiting for me, or you don't get it. And I need to know what it is, okay? Because if you don't get it, you need to let me know right now. So the conversion is 60 minutes. We want to get rid of minutes and we want hours to be on the bottom. All right, thanks for being honest. That's what I need, okay? I want to make sure that you're not just totally lost. So remember here, so look at what we have. We have beats. Well, we already have beats in our problem. We want to get hours, so we have to change these minutes into hours. We have to get rid of those minutes and turn them into hours. So we have to use this conversion, 60 minutes over 1 hour. So when you do this, don't do this with a calculator, just multiply 6 times 7, which is 42, and then put the 2 zeros on the end. Oops. All right, so come in, do you see what we're doing there? The 70 is not the time, it's how many beats in 1 minute. Okay, good. Yeah, if you just write this as your first piece, 70 beats over 1 minute, then you'll know what to convert. All right, perfect. We can do number 3 if you like. You want to do that, Megan? All right, so number 3. So same page. Number 3 says you buy a pump that is rated at 2,500 gallons per hour. So I'm going to write this down. 2,500 gallons per hour. And we want to know how fast it can pump liters in a minute. So we want to get to liters over minutes. So let's change the gallons into liters first. So our conversion, let's see, we don't have gallons to liters, but we have gallons into quarts and then quarts into liters. So let's do that. 1 gallon is 4 quarts. And now we can do the quarts into liters. So 1 quart is 0.9464 liters. So this gets us from gallons to liters. Now we have to get this hours into minutes. And again, we want minutes to be on the bottom so it matches what we have out here. So we have gallons gone, we have quarts gone, we have liters in the top, and now we're going to do 1 hour is 60 minutes. Now the hours are gone, and all we're left with is liters on the top and minutes on the bottom. And you just multiply across the top and divide by the bottom numbers. $157.7, that is what it is. So good job. I see Kendra and Megan and Kayla. Perfect. And it looks like Megan, you did that all on your own, right? Chemistry came in handy, yes. On some of these, they are chemistry applications. All right. Perfect. All right, so let's look at section 14 and see if we can get through this and have it make some sense. So section 14 actually has a lot, and it's about area and volume, first of all. And so area is like flat surface, 2 dimensions. Volume is 3 dimensions. So like I think of it like this. Area is like your rug, and volume is your mug. Okay, so rugs and mugs, rug is area, mug is volume. How much can it hold, right? So here it just has these simple conversions. Area for a rectangle is length times width, and then volume of rectangle. It's not volume of a rectangle because a rectangle doesn't have volume. It's a rectangular prism is what it actually is. The volume of a rectangular prism is length times width times height. So it's the 3 dimensions multiplied together. So area is square units, volume is cubed units or cubic units. So like inches squared or inches cubed. And that little 2 is really telling you how many of these units you're multiplying together. Twice. This one you're multiplying 3 of them together. And then for circles and cylinders, a circle is flat, so it's just area is pi, which is we're going to you can approximate with 3.14 or use the pi button on your calculator. In Indiana, there's actually a state law that says pi is 22/7, and it's for business calculations. So pi times the radius squared. That means pi times the radius times the radius. And if you have that line that goes all the way across, that's called the diameter. So you'd have to cut that in half first before you use this formula. And then the volume of a cylinder is that area of the base, the pi r squared, times the height to get that 3rd unit of dimension in there. So let's look at a couple here. Again, using the factor label method. So over on page 172 is where this first couple are. It says the factor label method can be used to convert between any measurements for which we know a conversion factor. This includes area, 2D, and volume, 3D, and rates relating multiple units of measure. So area is a 2-dimensional, values or measurements of a flat surface. And so this square is 1 inch long and 1 inch wide, so it has an area of 1 inch times 1 inch, which is 1 inch squared. So notice this little 2 tells us how many of these units we multiplied together. So if the sheet of paper is 8.5 inches by 11 inches, it's going to be inches squared, and just multiply 8.5 by 11 and you get 93.5. Okay. So let's look at this example here. It says convert 93.5 inches squared into centimeters squared. So now we're going from the US customary into the metric. So now when we have these types of units, it really is telling us how many times we have to use the conversion factor. Generally speaking, not, I don't want to say always or never, but generally this is going to tell us how many times we use the conversion factor. Because the conversion factor is just inches and centimeters. So here, if you look, you multiply by the identity ratios, we're changing inches squared, and they just wrote it as inches times inches. And then here's the first conversion to get rid of one of the inch units. And then here's the second conversion to get rid of the second inch units. Notice that we have 2 centimeter units left, and that's why our answer is centimeters squared. So let's look at this example on page 173. It says, you see an ad for an apartment to rent in Madrid that will sleep 5 adults. It is 90 square meters. How big is that in square feet? Because here in the US, we talk about square feet pretty often. So 90 square meters is 90 meters times meters. So we're going to have to change from meters into feet, and we're going to have to do that with 2 conversions. So, or more. So let's see what we have. We have meters. Do we have a meters to feet conversion? Do you see a meters to feet conversion? No, we don't have a meters to feet conversion, but we do have a meters to yards conversion. So let's do that. So we want the yard to be on the top because we want to get rid of meters. So we're changing from the metric to the customary, and we're doing it through yards first. So 1 yard is 0.9144 meters. Now the problem here is we only got rid of one of the meters, so we have to do this twice. 1 yard, 0.9144 meters. So now that gets rid of the meters squared, but what are we left with? We're left with the yards squared, and we don't want that. We want feet squared. So now we have to convert from yards into feet. And so we have these 2 yard units on the top. We're going to need them on the bottom. 1 yard, 3 feet. And again, we have to do it twice because we're doing area conversions here. So 1 yard, 3 feet. So that gets rid of 1 yard there, another one here, and we're left with only feet and feet at the end. So we're going to multiply 90 times 3 times 3. We're going to divide by 0.9144 and then divide by 0.9144 again. And then let's see how many square feet that is. All right, so I just put it in my calculator. Yeah, 968.7. I'm just going to go with 969, and it's square feet. Okay. All right, so the next example is same idea. Okay, number 3, 12 feet by 12 feet by 3 feet. The volume, you just multiply the 3 together. I have to skip through here a little bit because I want to get to the ones that are going to be more meaningful to you. So this is, what is that? 12 times 5 is 60. 60 times 3 is 180. So this is 180, and it's cubic feet for volume. Notice how we have 3 units of feet there, right? And then it wants to know what this is in cubic inches. So we'd have to take the 180 cubic feet, we'd have to convert that into inches. We'd have to do it 3 times. Okay, and that'll get us inches cubed. So number 5 is using the area with the circle and the height to make it a cylinder. And so here we'll look at this. It says the diameter is 8.8. That means that the radius is 4.4. So the volume of a cylinder is pi times the radius times the radius times the height and that'll get us the cubic inches. And when I threw it in my calculator, I got 437.9 or 438 cubic inches. Okay. So I wanted to make sure we saw these dosage calculations because these are going to be part of your assignment, and then also the CO2 emissions problems. Okay, so let's see. Number 2 deals with a lot of conversions here. So it says a certain drug dosage calls for 25 milligrams per kilogram per day. That looks like this: 25 milligrams per kilogram per day. And it says it's going to be divided into 3 doses. If a person weighs 250 pounds, how much of the drug should be given in each dose? So that's just my note here, okay? So here's how I would start this. I would take the 250 pounds, and this is how I would always do these. I need to convert them into kilograms so that my kilograms in that dosage will cancel out. So this is how I would always make these conversions. I have to change from pounds into kilograms, and we did this already. We said 1 pound is 536 kilograms. So that's the first thing we're going to do. Now we're going to put this dosage in here: 25 milligrams per kilogram per day. So notice how the pounds cancel out and the kilograms cancel out. Now we have milligrams per day, but we don't want the milligrams per day. We want the milligrams per dose. We want to know how much is in each dose. So it says that there are 3 doses. So we're going to have to do 1 day is 3 doses. And notice how days will cancel out, and we'll be left with milligrams over dose, so milligrams per dose. So 250 times 0.4536 times 25, and then divide by 3. That'll give us the number of milligrams per dose. All right, so number 3 says if a drug has a concentration of 375 milligrams per 10 milliliters, how many milliliters are needed to give 1 gram of the drug? So we're going to start with the weight again, 1 gram. We need to change it to milliliters because that's what's in this conversion factor. So we're changing from grams to milliliters, and we do have a conversion. And that is towards the bottom, I think. Milliliters and grams. Where is that on the sheet? Oh, we have liters. Okay. So 1 gram we'll start with. We want to get rid of grams and get into milligrams. So 1 gram is 1,000 milligrams. And now we can do our milligrams. There's what we're looking for. Milligrams per 10 milliliters. So we want to have 10 milliliters. 10 milliliters. And then the 375 on the bottom, milligrams, because we're trying to find the number of milliliters. We want milligrams to cancel out. And we have looks like 10,000 divided by 375. 267 milliliters. And if you need to go through that in the video a little bit slower, please do. All right, let me see what I have left for us here. Oh my gosh, so much. So we already did the dosage calculation. This is the same idea. You have to convert the weight into kilograms, and then here's the drug dosage, 125 milligrams per 2 milliliters, and 1.5 milligrams per kilogram. We're going to use both of the conversions after you change the weight into kilograms, and I'll tell you it'll work out to be 958 thousandths of a milliliter. So 0.958 milliliters, and you can try that one on your own. So let's see, in your book we have this idea of burning 1 gallon of gasoline and producing 19 pounds of CO2. And so let's just look at a couple of these examples, and then we'll look at the electricity ones, because the calculations are all, they're basically the same for these. So this first one says, we're talking about gallons of gasoline. We use 30 gallons of gasoline for 1 week. And we want to know how much CO2 is emitted. So we're just going to multiply that by 19.8 pounds of CO2, carbon dioxide, per gallon, because that's what this conversion is. And so we're just going to take 30 times 19.8. And that is, thank you, 594 pounds of CO2. Okay, so the gallons cancel out. So the conversion is 19.8 pounds of CO2 for 1 gallon of gasoline. Okay, so let's look at number 4, because that one's a little bit different. says if a car gets 26 miles to the gallon, how much CO2 is emitted if they travel 100 miles? So we've got to know how many gallons they used. So we start off with how many miles they drove, and then we're going to multiply that by their miles to the gallon. Now we want miles to be on the bottom to cancel the unit. So it's going to have to be 26 miles on the bottom for 1 gallon. So even though it's miles per gallon, we want to use the ratio with miles on the denominator. Now we have the number of gallons, and now we can just multiply by that 19.8. And we'll get our pounds of CO2. And number 3's answer, just so you have it, is 209 pounds of CO2 per tank. And then the electricity is the same idea, but we have to make one extra conversion when we're doing electricity conversions to pounds of CO2. So now the conversion is 1.37 pounds per kilowatt hour. So we have 1.37 pounds of CO2 for 1 kilowatt hour. So the difficulty here is we don't always know the kilowatts. We a lot of times know the watts. And a watt is just 1/1000th of a kilowatt. So what we're going to do with these problems is there's a chart on page 181 and 182. So 181 is the electricity usage and 182 is the we call standby power usage. And I know our time is up, but I'm going to still do this. If you want to hang on, great. If not, if you have to go, then I'll catch you later. It'll be on the recording, okay? But I do want to make sure I do these. So the first one here says, how much CO2 is produced from using a game console for 5 hours? We're just going to look up game console on page 181 and see how many watts it uses. And so let's see where that is real quick. Game console is on the top left, and it looks like 50. No, this is 50 watts. So what we have to do is we have to convert that into kilowatts. So 1,000 watts is 1 kilowatt. So that's the first conversion you have to do. Now our conversion factor into pounds is 1.37 pounds of CO2 for 1 kilowatt hour. So we need a time in there. And so the time has to be in hours, and in this case it's just 5 hours. And we multiply 50 divided by 1,000 times 5 times 1.37. Okay, I'm going to do one more, and then I'll close out the recording, okay? So I'm going to look at number 4, because it's a little more involved. Number 4 says, if someone sleeps with an electric blanket turned on for 8 hours each night during the 4 coldest months of the year, how much CO2 is produced? So we have to look up electric blanket, and that is probably in the bedroom, so bottom left. So it's 200 watts. And again, the very first thing we have to do is change this into kilowatts. So we're going to divide it by 1,000. Now we have to figure out how many hours. So this is the first piece right here. The second piece is converting into number of hours. So it says 8 hours each night. And we have to figure out how many nights that is, because we don't want nights as part of our units. Whoops, I don't want to put an equal sign there. So this is 1 night. We have to get rid of nights as a unit. So we want to know how many nights are in the 4 coldest months. So we just say on average there are 30 days in a month. So 30 nights in 1 month. We need 4 months. and that gets rid of all these time units. Nights cancel out and months cancel out, and all we're left with is hours. And now we can put our electricity conversion, 1.37 pounds of CO2 per kilowatt hour. So the watts cancel here, the kilowatts are going to cancel here, and then the hours cancel there, and we're left with pounds of CO2. And that looks like 263 pounds of carbon dioxide.